Welcome to Modular March. I'm Andy, this is Robbie, and we are the Rollup.
Modular March is an educational experience about all things modular. Enjoy.
Welcome back to Modular March. Today we have Anurag Arjun presenting Avail, the accelerating the unification of Web3. Welcome.
Thanks, Andy. Thanks, Robbie. Thanks for having me on this episode of Modular March. Welcome everybody who will watch this once this is pushed online. But yeah, today, I mean, it's like a pretty important deck that I'm going to take you across in general. So we are finally unveiling the final Avail thesis, what we call as accelerating the unification of Web3, and we will kind of go through what that really entails, what that means, what products that we have been building to kind of enable this new functionality, for example, and so on, right? So we'll go through these slides and understand more. And so before we get into the meat of the presentation in general, just to set some context on the problem as such, right? What has happened over the last 3 years, probably 4, is that rollups have really taken center stage. Rollups were derived, or in the first prototypes were implemented back in 2019, 2020, and in 2020 Ethereum also pivoted to the rollup centric roadmap in general. And so rollups as a construct started getting really popular 3 years back. Just for some context, before currently I'm co-founded Avail, but before I founded Polygon back in 2017, built of the a lot of the stack there in general. And in 2020, when we not some people know this, that Polygon used to work on this thing called Plasma, that was the predecessor to rollups. And so when rollups came into the picture, we at Polygon, of course, pivoted to ZK rollups, and within the same time, Avail, we started Avail within Polygon back in late 2020. So that was the core reasoning behind that, was that we were very confident in the rollup centric future per se, because we knew that rollups are a very nice construct in general, and this changes the fundamental way we view blockchains would scale. Because before rollups, what used to happen was that if you wanted to spin up a chain, you had to spin up a brand new chain, bootstrap a set of validators, come up with a new token, ensure that token is valuable so that it has enough cryptoeconomic security, for example, and so on, right? So that's why you'll see a number of chains out there, but only few of them have enough cryptoeconomic security. And so there's really a lot of friction to creating a new chain, and the rollup construct essentially solves that problem. So once this has come, now we are able to kind of experiment with variety of execution environments, variety of state models, for example, and so on, right? Historically, I mean, there's been a lot of EVM chains that have really stood out. Of course, there's now a bunch of other execution environments such as the Solana virtual machine and so on. But essentially, it still entails experimenting with setting up a new chain entails a lot of effort, right? Like, and that's why we have seen not that varied set of execution environment. And so essentially what I'm trying to say is that rollups are a very big shift in how blockchain infrastructure will be built going forward. And so we certainly believe that we are moving into a world where there will be hundreds and thousands of these rollups. Some of these will be, of course, EVM rollups, but we anticipate the vast majority of these will be app-specific rollups. And in the sense that we feel that app-specific rollup tooling will mature to such a point that it will be as easy as to deploy a app-specific rollup chain as it is to kind of deploy a smart contract today, right? Like that's the kind of maturity that these systems will reach pretty quickly in general. So just to set the stage, right? Like, I mean, essentially rollups as a construct have taken over. We already see a lot of rollups on Ethereum in general. L2Beat actively tracks maybe 40-50 rollups at least now. And like these coming years we are going to see a big increase in these numbers. So the point being that the rollup centric future is going to be the preferred way to scale execution on blockchains. And so rollups, we really need to scale rollups, right? Like we need to solve for rollups scalability. And so that's like the first leg of the problem that we started Avail with in general, right? Like when we started out, right? Like we said that we will need to solve for rollup scalability via building out a scalable DA layer. So that's where Avail DA comes in. And Avail DA is this state of the art validity proof driven data availability layer which implements data availability sampling. I think we are only the only project that implements data availability sampling with validity proofs, and this is some of the same technology that is going to be implemented in Ethereum in its dank sharding roadmap. Um, in general, so that's the rough background about like the rollup centric future in general, right? Like, but that's just the first problem in general that comes from like how we view the rollup centric future, where it is going, right? Like, so once we agree that rollups are going to be the future and they're going to be these tens and thousands of rollups, so you have to think out a little into the future. When you're building like a project or a company, you have to think 12 months, 24 months, 36 months into the future. And in general, what is already happening though is that as the number of rollups increases, the user experience is also getting fragmented, right? Like, I mean, users now have to deal with multiple chains. They will know, they have to figure out how to bridge from one chain to another. For example, if they want to do something cross chain, they have to go through a variety of third party solutions, for example, and so on, right? Like, so it's, of course, a lot of stuff of this is in development, but in general, you cannot deny the fact that the user experience fragmentation is real, and we can see that already playing out. So in general, that's really the second leg of the problem that like we at Avail have been building for, right? Like, so initially the first foundational layer we built is the Avail DA component, which is the more component which solves for the rollup scalability part. But once we enable these hundreds and thousands of rollups, then you have to deal with this user experience fragmentation problem in general. And so you really need this sort of unification framework to kind of sit between these rollups and sort of unify them so that like they can talk to each other, and so that like you can create this framework on top, so that users can then interact with that layer directly, and they do not need to deal with the underlying chain complexity. So that is the second leg of the problem that Avail really solves for. And so this is something we've been building over the last 1 year. For example, we've deliberately kept it out of, not talked about it too much, but we are kind of now announcing this in general. So the second component is really Avail Nexus, which does this unification of rollups, as we call it, via a combination of proof aggregation, execution proof aggregation, and validity proof based datability sampling in general. And to round that up, right, so once we have this foundational DA layer with a lot of rollups on top, and these rollups can talk to each other, for example, what we also have to optimize for is this whole coordination is to have the base layer to have a high cryptoeconomic security. And so there we kind of introduce something called Avail Fusion security, which essentially uses a combination of the Avail native token itself, of course, for securing the base layer, but we have been working on a construction where we are able to allow other high value tokens that already have value, like BTC or ETH, for example, to kind of participate in the consensus of the Avail network itself, for example. So this is roughly the three things that we have been working on, and we are kind of now making it public. So we call this the Avail Trinity. So the Avail DA is the base foundational DA layer. On top of it comes Avail Nexus, which is the coordination framework or the unification framework for rollups, and because of this unifying framework requires unified security, so we build Avail Fusion to augment the cryptoeconomic security in general. I'll just stop at the for now before delving into more slides. If you have any questions.
Yeah, I didn't realize that I was on mute. But so basically, the iteration here came from, okay, we're gonna build Avail DA to scale rollups that we see this vision of, app-specific rollups, thousands of rollups. We need to scale these rollups outside of just Ethereum DA. Okay, Avail DA. Okay, then the second order consequence comes of like, all right, now we've got to figure out to kind of put these all together and make them interoperate. Okay, so that's kind of like the next iteration. If we get from where we are today to a world in which modular DA is vastly accepted by thousands of rollups, then it's like connecting them. And then it's like, okay, we got to do all of that in the most secure way possible and kind of solve that next order. So through the iterations here, and we'll dive into each specific part. But really, it's striking to me that you guys are thinking multiple kind of steps ahead and really trying to like push a vision forward and kind of aligning your entire project on this vision and kind of taking a bet on app-specific rollups and this modular future. Yeah,
absolutely.
Ready to dive into each of the specific ones as well.
Awesome. So in general, we introduced the three different layers. So I'll just go through one by one for each. So Avail DA is something which we've already put out in the open. We have been kind of building this for the last 3 years. It's a validity proof based data availability layer that implements data availability sampling. As I said before, this is the only project that we know that has implemented data availability sampling in a validity proof based implementation, very similar to what Ethereum wants to implement on its dank sharding roadmap, for example. And in general, so we use this combination of KZG polynomial commitments and validity proofs to build out the implementation. The some of the characteristics of how we built out the base DA layer was that we used the substrate framework in general to build the node, because our tool stack is primarily in Rust, but essentially we also because of that we also kind of implement this consensus called grandpa and babe. So this is like a hybrid ledger consensus that powers Avail. There are a couple of reasons why we opted for that. Grandpa allows for a big validator set. At the moment, it allows for about 1,000 validators. And next year, we plan to upgrade the signature mechanism to a BLS one, where post that we should be able to scale that number up to 10K validators or more. So that's one of the reasons. But essentially, the Avail base DA layer itself is pretty lightweight, in the sense that it acts as a data availability, scalable data availability layer. It doesn't have any smart contracts. It has a minimal runtime for things like staking, transfers, and data submissions and such. But like the execution of programs is delegated over to rollups that run on top of Avail. So essentially, like what Avail DA really does is it kind of scales rollups, because blob space is abundant in the Avail DA layer. The core reason is because what is different here from a blockchain that combines both execution and data availability is that because we are implemented as a that Avail DA is a pure data availability focused blockchain, we are able to increase block sizes. So in general, when demand grows, we are able to grow the size of the block without changing too much on the like the verifiability side, for example, right? Like so again, some of these concepts, a lot of education has been done over the last 1 year in the industry on the data availability problem. But just to summarize, right, like so rollups really need to put their transaction order data on a base layer, right? Like, and of course it started with putting that, like Ethereum rollups put the transaction order on Ethereum, but the rollups are not specific to Ethereum alone, right? Rollups can be built on any blockchain in general. They just need some characteristics on the base layer, and one of the primary thing is to put the transaction ordering there. So Avail does that. But Avail also supports a lot of hybrid constructions where like transaction ordering data is sent to Avail, but let's say like a rollup sends the proof to Ethereum, for example, and so on. So but in general, like rollups are pretty hungry for data availability. Like in general, at the moment, like in the way current rollups are constructed, 90% of the running like of the rollup, for example, like there are various estimates, but 70 to 90% of rollup costs goes to kind of DA cost, for example. Of course that will change a little bit, but in general, like rollups are can be built anywhere in general. But rollups, the main bottleneck for rollups is that they need they're very hungry for data availability, and so that's the core problem that Avail DA really solves. And there is this component of data availability sampling that is slightly less understood. Like a lot of people focus on easy verifiability in the sense maybe users can verify the transaction order very succinctly. But yeah, of course that is a good side effect in general, that users can verify. But in general, it has much more powerful use cases, which we will kind of get into later. And that's one of the core reasons why we are able to use this to implement the Avail Nexus. as well. But in general, so we've been building Avail DA for some time now. We've been running testnets for the last one year or so, and we are on our final incentivized testnet. And mainnet for Avail DA is coming pretty soon in early H1 in general. So that's the bit around the Avail DA. There's a lot of technical detail which we can get into, but essentially, the main customer for Avail DA is primarily Rollups for now. There are other projects that also use it for more creative, innovative ways. But as we have been working with a lot of partners and customers in general, right? Like, so the primary demand is from rollups in general, and these could be app specific rollups, EVM rollups, non-EVM rollups in general, hybrid constructions such as Validiums, Optimiums, and much more. So that's really the backdrop of Avail DA. Yeah, any
Awesome.
questions on Avail DA? Happy to answer.
Definitely have one. I'm sure Rob does as well. Before we move on, when we were speaking with Prabal on one of our recent podcasts, we kind of dove a little bit deeper about the ZK proofs and the validity proofs with your DA layer. And one of the things that we talked about was how each user's wallet that's connected to Avail DA can actually run its own light node. Or something to that effect. The question is, how does using validity proofs for data availability offer more customizability and better verifiability for the end user and the rollup as a whole?
Yeah. No, I think that's a great question. In general, so what happens is, so you'll have to look at the kind of the life cycle of the rollup transaction in general, right? Like, so in general, when users send transactions to rollups, so like there are various ways to how a rollup can be implemented. Like, I'll concentrate on the most popular approach, which is that of a sequencer based separate sequencer based model. There can be base sequencing setups as well, but let's focus on the separate sequencer model, right? Like, so when a user sends a transaction, it goes to this sequencer. Typically, like most sequencers today also have an executor function which also execute this transaction as it comes, does some validation, for example, and posts transaction order data onto the DA layer or the base layer in general, right? Like, and if depending upon whether it's an optimistic rollup or a ZK rollup, assuming it's a ZK rollup, it will also post like a ZK proof, for example. An optimistic rollup sends a little like slightly different data, but it's essentially metadata that allows to run the fraud proof process, for example. Essentially, what happens is that once the data is sent to the DA layer, right? Like, so the why it is so important is that the ordering is the main guarantee that you require, right? Like, I mean, because if the order which you kind of execute a transaction is changed, it changes the meaning of the state transitions. So if you have, let's say, 10 transactions in a batch, or maybe 100 transactions or 10,000 transactions, right? Like, so the order is very important. If the order is switched or changed, for example, then the state transition can change pretty significantly, right? Like, so it's very important to have an ordering guarantee. So the word data availability is it's a very new, it's a slightly misunderstood sometimes, right? Like, because just of the way it is named, right? Like, I mean, some people also try to call this a data publishing. It certainly is a data publishing, is a slightly better nomenclature, for example. But the point is that, for a roll up, like, the ordering is important. Like, so the roll up has to commit to an order, and the base layer has to provide some kind of guarantee that this ordering will not be reverted. And so that's why, there's a lot of emphasis on the DA layer in general, right? Now once this is done, right? So what are these, when we say validity proofs or fraud proofs in the DA layer, what do they really mean, right? So essentially, you have this functionality where the transaction data has to be encoded in a certain manner, right? And that encoding has to be kind of has to have there has to be some proof whether the encoding was done correctly, for example, whether it was constructed incorrectly, for example. And this can be done in 2 or maybe more 3 ways as well. You can actually rerun the entire thing and check whether everything is right, for example. You can also do this in a more fraud proof based manner, where you have like a challenge window which could be in the order of minutes and hours or even days, and so you can play this fraud proof challenge game that kind of kicks in when an incorrect encoding is detected, for example, and so on, right? So there's a more cryptoeconomic way to do this. Avail DA does this in a very validity proof based manner, in the sense that we create these KZG polynomial commitments in the and post them to the header of our chain. And so there are these openings. Again, I'll not get into too much of the technicals just to spare you guys, but in general, what happens is, on the on the full node or on the light lines, you can actually create proofs of certain openings in the commitments, for example, and so on. And the beauty of this is that rather than indulging in a cryptoeconomic game in the fraud proof window, which might take probably minutes and hours, here, as soon as our our Avail DA block is finalized, which is most blocks get finalized within 2 block times, which is 40 seconds currently, 20-second block times into 2, and from that moment on, once finality is reached on the base DA layer, you have this separate P2P light client layer. So we actually so the Avail DA layer is actually not a single blockchain. It is actually 2 networks. So there is a validator run network, and then there is a separate P2P network of light clients. So these, you can think of this as a very torrent-like network almost, right? Where you have blocks being created on the main DA layer, and these light lines are fetching some data initially from the finalized block, and then over time, once there are more light clients, so when a new light client comes, it does not have to fetch data from the base DA layer. It just connects to another light client and fetches the data. So if you're aware of the seeds and peers in a torrent network, this is similar to that, right? So it basically over time creates a copy of the Avail of the data on the Avail chain onto the light client layer. We implement something called a Kademlia DHT. It's a distributed hash table implementation to store. So each light client stores small fragments of the data on the Avail blockchain for a period of time, for example, and so on, right? So okay, coming back to the question that you asked, right? Essentially what happens is that so when these light clients, these can create proofs from the commitments, and we have this erasure coding. Again, not getting to a lot of technical complexity, but essentially the main difference is that this process happens in basically very less time, right? By the time a block is finalized, you can actually immediately start creating proofs and verifying, as opposed to optimistic implementations, which would require you to wait for the challenge window period to finish, right? And why that is important is, when you want to verify this order, or the data availability guarantee in other systems, so of course users are able to verify, which is a good side effect, but the more important part is to if you want to verify this in other systems which are listening to these to a particular rollup, right? Like the fact that you can get this ordering guarantee in other systems pretty fast, that enables us to kind of also build something like Nexus, where like we combine that with, let's say, the execution proofs to then build out something like Nexus. So sorry for the long-winded answer, but just wanted to provide all the context.
Yeah, I think yeah, that's the differentiation between the two kind of chains is very helpful, as well as kind of the life cycle and the core reasoning behind the verifiability and the design choice. So I think we can move to, as you kind of pushed towards the Nexus slide, we can now kind of explain how that brings this all together.
Yeah. So yeah, that brings us to the Avail Nexus, which is the second part, right? Like, so as we explained in Avail DA, right? Like we went through the implementation and architecture a little bit, but essentially it provides this scalable DA capability. And so we can, as rollup demand increases, we can increase the blob space. And so we can enable these hundreds and thousands of these rollups on top, right? Like, but then what happens is, like you have, like as I said before, it like leads to user experience fragmentation. Like it's a lot of coordination work that is left to like other projects to implement, for example, and so on. So there are a variety of projects kind of like handling this. And of course Avail Nexus is like one of the, so we actually went really deep down to in order to architect this. So essentially something like an Avail Nexus is only possible if you have something like Avail DA data sampling, because it's a validity proof based approach. We are able to kind of now embed it into this layer on top, right? Like, so what Avail Nexus really is, it's basically a, you can think of this as a coordination rollup, ZK coordination rollup on top of Avail. And it basically provides two major functionalities. So this is not like a regular smart contract or application rollup. It's a more system sort of a rollup, and it provides coordination capabilities. So one is, of course, like a proof aggregation capability. So what we do is basically, like we are able to kind of take proofs from various rollups that kind of operate independently, for example, and then like compose these proofs together to create like single proof, for example. And so because we are able to do this within Nexus, then we are able to have one rollup have trust minimized access to the other rollup, right? Like because of the proof aggregation. Because essentially when we verify these proofs and aggregate them together, what we are really doing is, you take one proof from one rollup and maybe another proof from another rollup, and when you verify this together into one aggregate proof, it essentially means that this single proof then has trustless or trust minimized access to, or like guarantees to the correctness of the state transitions on each of these rollups, right? Like, so it's, so ZK proofs in that sense are like conventionally they have been used, or in blockchain conventionally they've been used in more of off-chain computation sort of a way. But validity proofs also have this wonderful problem attribute of composability, so where you can actually uh, know the state of the other blockchain, and you can like kind of rely on the mathematical guarantees of the validity proof in that sense. But in general, proof aggregation itself is not enough, right? Like, so you need to combine this with the ordering guarantees. So you need to know what was the order of this rollup, like what was the transaction order of this rollup, and the state proof or the execution proof of this rollup. And when you combine these together, then you are able to kind of now coordinate communication between rollups. And to be very sure, we focus on asynchronous messaging between rollups to start with, right? Like, I mean, the synchronous messaging primitive is slightly harder to do. I mean, it is possible with, things like block-based timeouts and such. But, like, essentially what we feel is that similar to how apps on the internet scaled via microservices, like, I mean, so if you look at, let's say, any app on the internet, right? Like if you look at Amazon, for example, and so when you make a purchase on Amazon, yeah, and it sends you to their payment page, right? Like, and so what is really happening in the background is Amazon does not handle the payment stuff, right? Like, it basically, there's an Amazon microservice sending a request to a Visa microservice, which then sends back the payment page, for example, and you put in your details. It gets validated again by the Visa microservice, and then it sends a response that, like, the payment is done, for example, or it failed, for example, and so on. So all of this happens very asynchronously, but it happens in such low latency speeds that the user hardly knows about this, for example. And so, like, today, that latency is something that we have not reached in blockchain till now. I mean, that's a focal point of a lot of solutions in general. But what we postulate, and we believe very fervently, that what is going to happen is that ZK proving systems have been, kind of maturing pretty significantly over the last 2-3 years, and there's been a lot of investment in the ZK system that the industry has been building. And we believe in the next few years, the latency for things like proof generation in general are going to become less and less, right? Like, and so what you will get to a point is that, like, latency will become very low. And so then you can posit that, like there will be there will still be these big rollups like EVM rollups, for example, and so on, which send, we have a lot of liquidity, for example, and so on. But we think that most use cases will be on these app specific rollups, which will have a lot of computation within their rollup. But whenever they require the services of anything on the other rollups, they will just do a asynchronous message call, right? Like, so it's similar to how, for example, when you want to load up, like, generally when you pay on Venmo, for example, right? Like, so payments on Venmo are pretty seamless, for example. But when you want to top up Venmo, you have to talk to another network, for example, right? Like, we think it's going to evolve in that direction. And so essentially, in this kind of a world, right, like, Avail Nexus is going to be key in general. Even today, there's a lot of fragmentation already that we are seeing between various ecosystems. So there are like rollup ecosystems that are getting popular in general day by day. But, like, if you kind of look at the big picture, everyone is looking to build their own ecosystem. And so now there are, and the fact of the matter is that there are so many great teams working on this problem. And so you have so many ecosystems, right? Like, and if you're a user in one of these ecosystems, it's the experience within the ecosystem is pretty good. But when you have, let's say, funds outside of the ecosystem, and then that user experience can be subpar in general, right? Like, and so what we really feel is, like, Avail is that kind of credible third party which can, kind of work with these ecosystems and to kind of create this permissionless verification hub that can, kind of unify these ecosystems together, right? Like, and so in a sense, that Avail Nexus is complementary to that in general. And of course, there is also a sequencer selection mechanism that we introduce in Avail Nexus. This is, as we said, there's going to be a lot of rollups, and today rollups sequences are run by teams, for example, and so on. But, like, once we get to, like, a figure above, like, let's say, whatever, 500 rollups or whatever, right? Like, I mean, you will see that, rollups sequencer are not run by the teams themselves, right? Like, they're being run by, let's say, rollup service providers and such, for example, right? Like, and in general, so you need some sort of select. So we don't run any sequencers as part of Nexus, for example. We don't run any provers as well. We just basically, from a sequence selection point of view, like for a particular rollup, if you can think of this as a more decentralized marketplace for whoever wants to run a rollup, right? Like, so you can think of this as an auction mechanism that chooses a sequencer, and anyone can come and bid in this auction to become part of a sequencer. So again, this is basically that part of the Nexus. Again, I'll just pause before getting into the last bit.
Awesome. So similar to the Venmo analogy, all of the rollups that plug into Avail Nexus layer will exist and interoperate like they're in the same network.
That's the end goal. Yes, that's the end goal. Like in general, essentially we acknowledge that there will be a lot of ecosystems, a lot of rollups, different rollups, and everyone has their own ecosystem going on. But between this rollups in this ecosystem and between different ecosystems, what you want is this framework on top, so that you can facilitate users to move from one rollup to another, or funds or liquidity to move from one fund to another, from one chain to another. And the end state, how we think of this is that think of Avail Nexus as this layer, and on top you have, let's say, users interacting with their wallets, for example. And the end state where we feel is that the user expresses their intent to do something on a particular chain, and maybe they have assets on multiple chains, for example, right? Like, and we assume that wallets will get more smarter. They will have track of assets on multiple chains, and then the wallet itself can talk to an Avail Nexus, for example, and then figure out what is the best path to do what the user really wants, right? Like, so of course we'll not build out this entire stack on our own. There will be smarter wallets, for example. There will be intent layers on top, for example, to coordinate that. But we provide the substrate for these rollups to talk to each other.
Got it. And earlier in the last slide, you kind of hinted at a bullish kind of thesis towards other virtual machine structures and other kind of rollups with different settlement layers, different virtual machines. You mentioned SVM, for example. Is Avail Nexus in its state that it's planned to launch, will that be able to interoperate with every type of virtual machine in terms of customized app-specific rollups, general purpose rollups, ZK, optimistic, as well as different settlement layers? Or is this just for Ethereum settlement layers? How flexible can Avail Nexus be to accommodate all the various types of rollups that we'll see live?
No, it's a good question, valid question. Yeah, so let me try to frame it in like two answers. So the first answer is that our focus currently is primarily because it's a proof aggregation based mechanism. So the focus is initially on the more ZK rollups to start with, right? Like, so that's the design we started with. The next focus is to, like, once we have we roll out ZK rollup support, for example. We are also experimenting a little bit with how do we do this in a more optimistic rollup sense, right? Like, so optimistic rollups have to be handled slightly separately, but we are experimenting with things like consensus proofs, ZK consensus proofs and storage proofs, to also add optimistic rollups to support to the Nexus in general. From a non-rollup, from L1 perspective, like a non-rollup chain perspective, the ingredients that we really require are things like like consensus verifiers, for example. So consensus verifiers and state verifiers, and so we've for the last 1 year, we have been kind of working with internally and with other partners to enable these different sort of consensus verifiers. So we use this consensus mechanism called grandpa. So our we built something called vector x, which is a grandpa verifier, zk grandpa verifier, for our chain. But the same consensus is also used by, let's say, Polkadot, for example. And our partner Sassin Labs also previously built out the Ethereum sync committee consensus verifier, which when we are able to kind of verify Ethereum's consensus, at least the sync committee consensus. So there we are able to add Ethereum rollup support, for example. And they also built out a tendermint verifier, zk tendermint verifier. So you can think of using that to connect to Cosmos chains. So there are a few elements that you require. So for example, to answer the question around the SVM, essentially theoretically the framework should support any sort of L1, but it also depends on the complexity of building out the consensus verifier, the state verifiers, and so on. And Solana particularly, or the SVM, right? Like, so there's the SVM element, but there's also the Solana consensus element. So we need to have built out the Solana consensus verifier, for example. And so there are efforts in the Solana ecosystem, for example, that work on building out light client verifiers, for example, or for the consensus in general. And so we will monitor those developments. But essentially, so the answer is in two parts, right? Like, theoretically, yes, it might be possible. Practically, there has to be a succinct practical implementation of some of these primitives, which today are not there. It might happen in the future.
Thank you for that. I'm certainly excited. It feels like with the ZK realm, it's like every year it gets closer and closer and closer. So
yeah, makes sense. I also mindful of the time, I will just kind of also get into the final part of the Avail Trinity, which is called Avail Fusion. And so basically, because we I've already explained in terms of, because Avail DA enables these lot of rollups, and Avail Nexus then kind of unifies them into a coherent whole. In general, to power this ecosystem, we also require this the shared security layer in general to be pretty robust in terms of cryptoeconomic security. And so we riffed on a lot of designs, talked to a lot of teams who have been working on similar problems, and arrived at kind of this design in general. But the point is, the core idea is that, like, currently the Avail DA chain uses the Avail native token to power its consensus, and so it depends upon the value of the Avail token to define its cryptoeconomic security. And so, of course, we hope it will be enough in general, but we also have the ability to leverage other tokens from other ecosystems to kind of add to the cryptoeconomic security. And so we kind of some these ideas kind of inspired from the mesh security system from Osmosis, for example, in the Cosmos ecosystem. Some from like EigenLayer, for example, but Babylon chain also is doing something in the BTC. And so so these are all projects and friends who we talk to for advice and sounding board. And in general, so we kind of got inspired from the designs. And but this is slightly different from like, let's say, like just EigenLayer restaking. So it's basically we are able to take any foreign asset like BTC or ETH and power the Avail consensus, and you, instead of slashing happening in a contract, you have slashing happening in protocol, right? Like, so that's one of the major differences, and it's a slightly different design than other approaches. But this has been inspired primarily from I would say mesh security in general. And this is because we want this unified layer to have higher security, and what best than to kind of like take some tokens which are already valuable, and then put them in a game theoretical manner on to power the consensus. So that's one of the core insights behind Avail Fusion. There is another small element that is also pretty important, but like we will expand on that later. Is that like along with other valuable assets, we also want to add in a small provision for new rollup tokens to be added to it, because when you think that you have these rollup tokens new rollups coming in, and tokens rollups releasing their own token, the utility of the token itself is a little weak in general. And so if we are able to kind of accomplish this and to allow new rollup tokens to also participate in Avail Fusion, like that's added utility for the rollup token itself. So in general, so that's one thing that we have been like we plan to put in general. So yeah, in general, just to sum it up, right? Like, I mean, so these are the three elements of the Avail system that we wanted to talk about. And in general, like we strongly believe in the roll-up centric future being the future of blockchains, and so we solve the problems, strive to solve the problems of what constitutes that future in these three parts of the Avail stack, which we call the Avail Trinity. Yeah, I'll just pause and stop for at this moment. Yeah.
Andy, you're on mute. I'll just quickly read this. Avail accelerates the unification of Web3 by enabling modular execution layers to scale and interoperate in a secure and trust minimized way, which I think is very powerful given the fragmentation of rollups now. And as new rollups come out, the greater fragmentation, it calls for unification more and more as that happens. I have a quick question on Fusion. As new rollup tokens are added into Grandpa consensus, if let's say there's an illiquid token because it's a brand new rollup and it has some really significant volatility, would that volatility perhaps to the downside affect Grandpa consensus? Or I imagine because Bitcoin and ETH are also considered cryptoeconomic security for this consensus mechanism, that provides the bulk of the security, and a single one of these new rollup tokens, going down and going bust does not impact the consensus to a significant measure.
Yeah. So I mean, of course, like we have to tread very carefully, when it comes to like adjusting that. So in general, like you can anticipate that new rollup tokens will constitute only a very small percentage of the total economic security, because of course, because these can be very highly volatile and illiquid in general. And so you can think of the Avail Fusion as this set of separate quorums of various tokens. So there will be the Avail token having a quorum. Like BTC quorum is different, and ETH quorum might be different, and these rollup tokens will also have a separate quorum, right? Like, and but together, like yeah, it will we of course, there will be a lot of training levers on this functionality, for example. So you can think of this very much similar to, let's say, like a gradual onboarding window where we kind of vet these assets that can come in, for example. And certainly for the new rollup tokens, we'll keep it very like risk adjusted and very small portion of that, right? Like, because unless, like, you can think of there being like a very like it being a very small part, and if it grows big, then it grows like gets a much bigger percentage of the pie, that kind of a thing. So I mean,
Yeah.
again, we are still doing a lot of economic modeling and like what if scenarios, for example, and so on. So we, of course, like we are going to be very careful rolling this out.
Yeah. I want to be mindful of the time as well. I appreciate you coming on. I just want to ask one last thing about Fusion as well, which is going to be short. What does Grandpa consensus stand for? Where did Grandpa come from?
Yeah, so Grandpa is basically like this consensus protocol that was created by the Polkadot folks in general. So Polkadot, like Substrate or Polkadot in general, has this hybrid ledger consensus where they have this. So Babe is the block production protocol, and then there is a Grandpa, which is a finality protocol. So essentially, it's like a hybrid finality ledger, in the sense that you have a block production protocol that goes on, and in general, Grandpa kind of will come in and finalize a set of blocks at some interval, right? Like mostly it will kind of immediately finalize blocks, but it's so why this distinction is different, because it's slightly different from instant finality protocols. So for example, instant finality protocols like Tendermint, if there is a finality, like if there's a problem, the chain halts, right? Like, I mean, essentially the block production also halts, for example, and so, I mean, there are different trade-offs to doing which, different kinds of. So basically, in Grandpa, like in Avail, for example, you have Grandpa and Babe, where Babe block production handles the block production, and Grandpa then is like a finality gadget on top of it, in general.
Yeah. All right. It's just
Yeah.
quite a funny name.
Yeah. I mean that. I mean, I also put out a tweet said, like Grandpa and Babe memes are very like underutilized.
Yeah, coming soon on the Rollup. Thank you, Interreg, for coming on and sharing some of the broader vision of Avail, the Avail Trinity, and generally accelerating the unification of Web3. Really enjoyed it.
Yep. Thank you very much for having me, guys, and very wonderful to meet you as well.
Likewise. Thanks.